Okay, welcome you all to this 8th lecture, and from today's session we are going to start another major half of this course, which is on design patterns. Before I start, I'll just take up a few quick queries if there are any. So there are questions that if tomorrow the last date for submission of the assignment, officially as per the announcement that I made on the portal, yes, tomorrow is the last date for submission. However, while configuring the submission folders, I intentionally gave the date as 24th, which I thought would not be visible to you people, but unfortunately it is visible. The reason was just to avoid last minute delays. So if there might be a shutdown of the server side, or maybe some internet issues with a particular person, and if you're not able to submit on time, so I just kept a margin of 1 or 2 days for submission, right? So it is there, so you can submit it till 24th, but officially the date is tomorrow. And if you are done with your assignment, it's good to submit it on time by tomorrow, right? Instead of loading the server on the last hour of the submission time. Okay, I think that is the only query, and I have been trying to answer most of the mails that have sent to me regarding the assignment, submission, etc. In case you still have queries, feel free to write to me. I will reply as and when possible. And once all the submissions are done, because there are a lot of mails regarding change of groups. So once the submissions are done, I will evaluate these submissions, collate them, and then reform the groups as per the assignments that you have submitted, and upload the modified list onto the eLearn portal, so that you can cross-verify it. And in case there are still some issues, we'll resolve it. Regarding the evaluation, it's still going on, right? So you will get an intimation from the WLPD division, and it's still in progress, right? So we had mid-semester answer sheets, and now we are having the regular ones, and now we are having the makeup ones that are coming up, right? So it will take, I think, 1 week to 10 days. But whatever the update is, I will share it with you. I think that's it for the queries. I'll take up if there are more. So let us start now with the first session on design patterns, right? Let's try and understand what are design patterns. I think many of you are aware of what are design patterns and have used also quite a few of them. But still, to add to it, I'll explain what does design pattern means in the first go, and then we will see 3 important design patterns of the part of gang of 4 patterns, right? Okay, there's a request for a volume check. Right, please check the volume at your site. Okay, so in software engineering, a design pattern is a general reusable solution to a commonly occurring problem in software design, right? So there is a capturing of a common problem which occurs usually when you design an object-oriented system, right? And this problem is so common that it has been documented, and not only the problem is documented, its solution is also documented, right? And this is what is termed as a design pattern, right? A solution to a commonly occurring problem is described as a design pattern. Now, in order that a large number of audiences can understand uh, the solution, the design pattern that is given, the design pattern is written using a defined template, right? So there is an elaborate template of the design pattern. You can find it in most of the books, even in our textbook, right? So it first explains the template. By template, I mean that first it explains the problem at hand, the context in which that problem arises, and then the possible solution and a number of more formats that are associated to it, right? So a design pattern is described using a template, which is a standard template, so that it is easier for a larger audience to understand the solution for the given problem, right? So in order to understand the design pattern, it is very important that first you are able to understand the problem that is in hand, the context or the scenarios in which that problem arises, and then how is that solved using the given design pattern, right? Design patterns usually provide a solution in terms of a object oriented design, right? So it mostly works at a design level, but yes, it is explained using implementation as well, right? In our textbook, if you go around, you will find the details of the design patterns, and again, it is the point of sales case study which is being used to explain each design pattern, right? Okay, let's move ahead. The object-oriented design patterns typically show relationships and interactions between classes or objects without specifying the final application classes or objects that are involved, right? So they always operate at a higher level, wherein the design patterns try to explain a solution in terms of a higher level design, right? You can, and in fact we will also see how the design is also implemented, right? So that is also important to understand the design. However, at a higher level, the design pattern explains specifically the design aspects that have to be used while solving the particular problem, right? Okay, let's see what are the benefits of design patterns. So design patterns, as they were defined or described for various problems uh, occurring in the object-oriented domains, these are designed to take care of the various uh, fundamental aspects that an object-oriented system must follow, right? So most of these design patterns, if you see, they encourage cohesion, they discourage coupling, right? And so many other principles which one must take care while designing an object-oriented system, right? These principles, which are also called solid principles, and there is another set of patterns which is called grasp patterns. All these I will take up more in detail in the coming lectures. They are a part of your course. However, to talk at a higher level, we do understand that every object-oriented system must adhere, the design of an object-oriented system must adhere to these principles, right? So it should, the classes should have low cohesion, uh, it should have high cohesion, should have low coupling, there should be reusability of code, they should be designed that they can accommodate change, etc. Right? So design patterns, the solution that these patterns propose is also based or is also designed using, keeping in mind these object-oriented aspects, right? So design patterns encourage code reuse and are designed to accommodate change. These patterns can speed up the development process by providing tested, proven development paradigms, right? So they provide a highly uh, good design which can be which can easily accommodate change, which actually speed up the development process, right? Design patterns encourage more legible and maintainable code which can be easily understood, right? So these are the aims with which the design patterns are described, or these are the solutions, these are the design solutions which a design pattern uh, proposes, and these solutions, they are designed by keeping in mind the various object-oriented um, aspects that should be there in an object-oriented design. Okay, to start with, we will see the gang of 4 design patterns. There are something around 6 to 7 design patterns which are there in your course. And just to add before I start, the lecture slides, the video lectures that are uploaded on the eLearn portal, they start with the grasp patterns and the solid principles and then the gang of 4 patterns. However, in these lectures, I will start first with the gang of 4 design patterns and then take up the rest of them later on, right? So these gang of 4 design patterns were proposed by these 4 researchers, and that's the reason they are called gang of 4s. These 4 researchers, they proposed 23 design patterns in the year 1994, and these 23 design patterns have been further categorized into 3 categories: creational patterns, structural design patterns, and behavioral design patterns. So these 23 design patterns are subdivided into these 3 categories. We do not have all the 23 of the design patterns in our course. We have around 6 to 7. 3 of these we will cover today, and rest of them we'll do it in the next session, and that will finish the gang of 4s, and then we'll move ahead with the remaining patterns. So let us first see these categories. What are creational patterns? Creational patterns provide instantiation mechanisms, making it easier to create objects in a way that suits the situation, right? So they are basically related to the concept of creating object. And that is the reason they are called creational patterns. When there are issues or problems related to creation of objects, we'll see 2 of them, that when do we have such kind of problems, then these creational patterns help us and provide us design which is better and suits the given situation. The next type of design pattern category are structural design patterns, right? So as the name suggests, they help in solving certain structural problems that might exist in a given context, right? The problems that deals with the relationship between the various classes that exist in a particular object-oriented system. So these structural design patterns are aimed at providing a cohesive structure which is better in solving the given problem at hand, right? And then finally, there are behavioral design patterns which provide proven solutions to enable effective communication between the various entities existing in the object-oriented system, right? We will see each one of them in detail. So let's start today with the creational patterns. As I've already discussed, these creational patterns are concerned about class instantiation. So wherever there is an issue related to creation of objects, and maybe if there are issues like a larger code, complex code is required to instantiate objects, how do you deal with that kind of a problem, right? So creational patterns are the ones that create objects for you rather than having you instantiate objects directly. Okay? Okay. That's making it more abstract. So let's get down to a more deeper concept. Let us see the first pattern that we have in store for today's lecture, which is called the factory pattern. right? So this is one of the creational pattern. The rest of them that exist in this category are singleton, builder, abstract factory, and prototype, right? And we are going to see the factory pattern and the singleton pattern today. And these are the two creational patterns that are there in your course. Okay. Um, let's immediately start with the factory pattern. So let's first understand what does the factory pattern, what is the problem that the factory pattern aims to solve, and then we'll see the implementation of the factory pattern for a given scenario, and we understand that how the factory pattern helps to solve the given problem, right? So the problem that the factory pattern aims to solve is that who should be responsible for creating objects when there are special considerations such as complex creation logic, a desire to separate the creation responsibilities for better cohesion, right? So this will come back to this problem again when we have the solution with us, right? So then the solution will in fact help us understand the problem in a much better way what we were trying to solve, right? But in a quick nutshell, the idea is the factory pattern helps us or provides special consideration in case there's a complex creational logic that is involved, right? And the solution that it proposes aims to increase the cohesion of the design as well as keep in mind the concept of separation of concerns, right? The solution is create an object called a factory that handles the creation. Okay, there's one question. What do you mean by complex creation logic? I'll explain you. I explain that with an example, and then you'll understand what I mean by a complex creation logic. Okay, let's quickly move to the example. Now, this is the example. Suppose that a cake store offers 4 types of cakes, okay? And it has the following design and the code. The code we'll see ahead, but it has this design, right? So this cake store, it has a cake interface, okay? Sorry, I forgot to write the word interface on top of it. So that would be a correct UML notation. So this is a cake interface, right? The interface provides 4 methods which every type of cake should implement, right? So there is a prepare method, bake, decorate, and box. Okay, so every cake class which implements this particular cake interface must provide implementation for these 4 methods, right? Additionally, there are 4 types of cakes which are offered by the cake store. So there are vanilla cakes, pineapple cakes, chocolate cakes, and butterscotch cake. Okay. Um, if you see carefully, this particular design, which is already existing for a cake store, wherein the cake, the main interface is defined as cake, which provides 4 methods which every type of cake should implement, right? This particular design follows an important object-oriented principle which is called code for an interface. Okay, it is always encouraged that in an OO design, one must go for this kind of a system wherein you try and collate the important functions that every subclass is supposed to implement into an interface, and then every class which is of different types but is required to implement the same interface, right? This aspect is called code for an interface. I will not jump to the code for an interface example right now, but I have an example for code for an interface in the lectures itself. In today's lecture itself, if time permits, I would discuss that as well. However, if I do not discuss that one, I would still upload those particular slides into onto the lecture slides, right? So you can go through them, right? So it is very important that uh, it is encouraged that in object-oriented design, wherein you know that there can be n types of a particular type, right? And all those n types are expected to implement or predict certain kind of a behavior. Then you collate all those behaviors into an interface and make the different types implement that interface, right? So this is the current structure of the cake store, right? Let's move ahead and understand the factory pattern, right? So let's not get lost in the code for an interface, but we'll understand the factory pattern first. However, before that, the idea is that this design which is there for a cake store is a good design. It's a good overall design because it's based on the code for an interface concept, right? Okay. Now let's move ahead and understand the factory pattern. Okay, this is my cake store class. Let me just zoom it in. I think it's not visible, very small. It's written. Okay. I hope it's visible now. All my animation is gone. Anyways, we can still understand it, right? So this is the cake store class. Okay, I hope it's visible. The cake store class, let me go line by line. So my cake store class has a method called order cake, right? And it takes in a string type, right? Now this is the type which tells me which kind of cake is required. Okay, so I first create an cake instance of the cake interface, right? And based on the type which is passed in the type string parameter, right? I instantiate an object of that particular cake, right? I hope it's clear. So in case the string contains vanilla, then I create an object of vanilla cake and assign it to the cake instance, right? Similarly, if it is butterscotch, then I create an object of butterscotch. Then moving ahead, if it is pineapple cake, then I create an object of pineapple cake. Otherwise, if it's chocolate, then an instance of chocolate cake, and then finally default, if something else is specified, then it is by default a pineapple cake, right? Now, if you understand, take a deeper look into this. All this is the creational logic, right? So all this is the creation logic, which is the complex creational logic that I was just discussing, which is required in order to find out which type of cake has to be created for the given scenario, for the given order, right? So based on the string type that is passed, one needs to determine which kind of cake is to be created, right? So there is a complex creational logic that is placed in the order cake class, right? And then the rest of it is the preparation. So once you have the cake object with you, you say cake.prepare, bake, decorate, and box, right? So this is my entire logic, and then finally you return the cake object, right? So this is the entire logic which is there inside my cake store class. right? There is a method which is order cake, which requires a complex creational logic for creating the type of object that is required based on a incoming input parameter, right? Now you can even visualize how this particular creational logic uh, can become more complex if I have, say, 10 types of cakes, and every cake might even have a different maybe shapes associated with the cakes, right? So then this creational logic becomes more complex, right? Okay, let's move ahead. Let me just zoom it back. Okay, so the issue is that my cake store class consists of code for two important processes. One is the creation and the other is the preparation of the cake. This violates the cohesion principle. Okay, this is violating the cohesion principle. My cake store class is effectively doing something which it is not supposed to do, right? It is getting involved in creation of the cake objects, and right, so it is the order method which is actually getting involved in the creation of the cake objects rather than preparing it, right? So um, it is lowering the cohesion of the cake store class, right? I will just quickly explain what do we mean by the cohesion principle. The cohesion principle states that a class must do only the tasks related, uh, only should only be responsible for doing related tasks, right? So if a class is doing some task which is highly unrelated to it, then you are reducing the cohesion of that particular class, right? So in our case also, your cake store is actually getting involved in creational logic about the cake objects, which it is not supposed to do, right? So a better way is to move the responsibility of the creation of objects into another class, and we term this class as a factory class, right? So all the creational logic is moved to a factory, and the factory is one which is responsible for creating the object based on n number of if then else's, and my cake store is only requesting the factory to give it an object of the cake that is requested, and then you just prepare and bake and decorate and box the cake when an order is placed, right? I'll just take up a few questions that are moving. Will we be asked to write codes like this in comprehensive examination? You may be asked to write some code, although the issue of Java and C++ comes in picture, right? But if you see some past papers, there have been some questions on writing implementation for a particular concept, right? But it is very less likely. I mean, it's, or maybe the percentage of marks for which it is asked is very small, right? So you need not worry so much about it until and unless you are aware of the Java programming language. Cake is a superclass. What if bake method is different for each type, right? So every type of cake actually implements its own uh, bake method, prepare, bake, decorate, box method, right? The cake is not a superclass. Cake is an interface. Each of the class only implements that interface and provides implementation for each of the four methods, right? So it is only a handle of that interface which is assigned to that particular object of that particular class, right? And if you invoke, I'll just go back to the code. So the moment you invoke cake, cake.prepare or cake.bake or cake.decorate, so these are the methods of the respective uh, cake objects which will be invoked, right? In the interface, the methods are not implemented. Okay, okay, fine. We'll move ahead and let's take up what what is the solution that actually the factory patterns provide us, right? So the factory pattern tells us to move this complex creational logic into a factory, right? Now we term this as the cake factory. Let's understand this solution, right? So we'll first take a look at the right hand side, which is my cake factory, right? This particular class is the cake factory, right? It has a method called create cake in factory, right? And the same string is passed to this particular cake factory, right? Now, based on the type of the string, it creates the respective object, whichever should be there, and returns that object, right? So it returns a new object, right? And this object gets assigned using uh, the instance of the cake interface, right? Now let's go back how this factory is invoked. So coming back to the modified cake store, right? So in the modified cake store, you create a variable, you create an attribute of the cake factory, okay? This attribute is initialized at the time of uh, the creation of the cake store, right? So it is in the constructor of the cake store that you initialize the cake factory object that is there in the cake store, right? And then in the order cake, instead of writing the entire creational logic, you request a cake from the factory by invoking create cake in factory and passing the type string, right? So based on the type string, the cake factory invokes the create cake in factory and returns the corresponding object which is further used in the preparation of the cake, right? So this is an example of a factory pattern that helps in moving complex creational logic into a class which is called factory. My factory is the only class that would be responsible for creating objects the of the required type based on the given input from the user, right? I'll just take up a few questions. Uh, okay, that's a good question. I'm new to Java. Can we write the class code in Python? Uh, it's a complicated question to answer because usually the code is expected to be written in Java, and in case there is some code that you might find given in the question itself, it would be in Java. However, I would still say it is highly unlikely that you would be asked any question which is language specific, right? It would be highly unlikely that you would be asked any question which is language specific, but if there is some question, it will be only on Java, right? Okay, I really don't understand the question. How is creation important than preparation, right? What I understand with this question is that why am I moving the creation concept into another class instead of moving the preparation concept, right? See, the idea is that because my creational logic is a complex logic, right? So this is a very simple example that I've taken, which is based on cakes and etc. etc. Right? There are large number of complex examples that would be there, wherein the type of object that has to be instantiated is based on a complex logic, right? Even complex than this. The main class should not get involved uh, in actually implementing that complex creation logic and getting involved into an highly unrelated tasks, right? Also, additionally, there might be some other classes which would require uh, the similar kind of object instantiation, right? So in that case, those classes will also redo the entire creational logic in their code itself, right? So instead of putting the creational logic into two separate classes, right? Why not club it into one class, which is actually termed as factory, right? So that every other class in my system which needs object based on the type of the parameter is able to take that object from the factory and use it the way they want it, right? So the word factory is actually given to such classes in order to emphasize that this is the place where the creational logic is stored, right? You can take it from here, right? The word factory is, it's like a industry standard, right? So you understand the factory pattern is being used here, and this is the place which is kind of a factory of object instantiations, right? This is the place where the required objects would be instantiated and returned back to the system, right? It in this case it is a cake factory, right? A more familiar analogy, or a more another analogy which is more technical in the sense. So there might be an analogy where you need database objects, right? So you uh, keep the concept of creation of database connection objects in a place which is termed as factory, and whenever an object is required, right, it is returned from there, right? So that kind of an analogy is placed with the concept of factory, that this is a place where the objects can be taken from, right? I hope I am making sense. Okay, let me just take up a few more questions. Okay. Um, okay. So there's a question that what is the purpose of initializing cake factory and cake store constructor? We can use cake factory dot create cake factory method by calling it, right? At present, you cannot make that invocation because my create cake factory is not a static method, right? You can please note that it is not a static method. But the reason why this question came in your mind is that uh, is something to follow, because the factories are always implemented as singletons, right? And that is the next pattern that we will see what a singleton pattern is, right? A factory is always implemented as a singleton, and once we go to the singleton pattern also, we will redefine, we will re-implement this particular cake factory to implement it as a singleton, right? And once we do that, then this kind of invocation that you are mentioning will be possible, right? Okay, I will continue to take up more questions, but at present I will move ahead. Okay, I got this question. So there's a question, do we have multiple factories? Factories are always implemented in singleton. I did not implement it here at using a singleton pattern because it would confuse you. Let's first understand the factory pattern. The next thing we'll do is that we'll understand the singleton pattern, and then we will merge both the two implementation to see how factories are implemented as singleton, right? But as of now, I hope that the factory pattern is clear, right? So you move the creational logic, which is actually taking most of the space of the order cake method. So it is taking most of the tasks of the order cake method and making it do highly unrelated tasks, right? So the idea is to move the complex creational logic into another class. You can name that class anything, but just to have a standardized name, it is given a name which is uh, suffixed or prefixed with the word factory to explain that this is the implementation of a factory pattern, right? Just to add, this kind of a concept is what you would be required to actually implement and explain and design uh, in the next phase of the assignment, right? So in the next phase of the assignment, you would be asked to implement first design and then implement some of the chosen design patterns for the system that you have already designed in phase 1, right? Okay, I'll just take two quick questions. Okay, okay. I think the questions that are there, I would be able to answer in a better way once we do the singleton pattern as well. So let us move to the next slide. So the factory handles the details of the object creation. So this method allows us to place the abstract code to an interface code into a superclass or an interface and place the object creation code in a subclass, right? So that was the factory pattern. Let's move ahead to the next pattern, which is the singleton pattern. Okay, let's see what is this singleton pattern tells us. So this is the next kind of the creational pattern that we will take a look at. The singleton pattern ensures that a class is only instantiated once and provides a global access point for this instance, right? So the singleton pattern aims that there exists only one instance of a particular class and every other class in the entire system is able to access that single instance of the class, right? Which are the classes which are implemented as singleton patterns or usually are the best candidate or in fact the required candidates to be implemented as singletons, right? Any class which is responsible for, say, recording or collating the uh, combined information of all the classes in the entire system is one that is responsible for, is the one that should be implemented as a singleton, right? So all the classes a class which might record information about all the other classes or may provide resources to the other classes are good candidates to be implemented as singleton, right? By singleton, we mean that only a single instance of these classes should exist, right? So examples of certain classes which are good candidates of singletons are, for example, a database manager, right? So any class which is responsible for managing data, connections, as well as the other database interactions is a good candidate for being a singleton, right? By saying singleton, we mean that only a single instance of the database manager should exist in the system. Similarly, for another example could be the error log manager, right? So a single instance of the error log manager is what we need in the entire system, right? The other example could be a Windows manager, uh, a single instance of a file system, or a single instance of a service factory, right? So every factory that you might implement in your system must be implemented as using a singleton pattern, right? There should be only one instance of the factory in the entire system, right? Coming to the point of sale system that is discussed in your textbook, there is a register class which is there in the point of sale system, right? So I hope by now everybody would have read the point of sale system. So there's a register class which actually records all the sales, right? So that register class is an important candidate to be implemented as a singleton, right? So it is a place where all the sales are recorded, right? So any class which is responsible for say recording or providing information has to be implemented using a singleton, right? Let's move ahead. Let's see how the singleton is implemented. The issue with the singleton pattern is that how do we ensure that the class has only one instance and that instance is easily accessible, right? So when we say that only one instance of that class should exist, how do we actually do it, right? So do we make a global variable out of it, right? But this violates encapsulation. If I make a global variable out of um, uh, for that particular class, right? What I'm doing is that I'm violating encapsulation, right? But could be done, right? So I make a global variable and that variable is the one that I keep on passing to the other classes whichever need that particular variable, right? However, although this particular aspect violate encapsulation, but this particular solution does not prevent creation of multiple objects, right? Even if this solution works good for you, even if you are ready to violate encapsulation and make a global variable and pass it on to the other classes whichever need to access that particular instance, it still does not prevent the creation of multiple objects, right? So we need to find a solution to implement a singleton, to implement a class so that only one instance of that class is created and can be created, right? Only one instance of that class can be created and also that instance is globally visible to all, right? So every other class that needs this particular instance is able to access it, right? So the better solution to make this happen is make the class itself keep a track of its own instance, right? So the singleton pattern tells that for this, make the class itself responsible, and we'll see how do we do that, right? So the class itself, so the class which is implemented as a singleton itself ensures that no other instance can be created, and it provides a way to access the single instance that exists, right? Okay, let's move ahead. The implementation would help in understanding more, right? So this is the singleton pattern. The problem that it tries to solve is that exactly one instance of a class is allowed. Objects need a global and single point of access, right? So if we have a problem wherein we want that only one instance of the class should be there, but it should be accessible to all and no more instances. Uh, Creation of more instances should not be possible, right? So what is the solution? Can make an object globally accessible as a global variable, but this violates encapsulation, right? The other possibility is use of static operations and attributes, but uh, because of this, polymorphic redefinition is not possible. So if we make all the methods and attributes of a particular class static, right, this would in some ways solve the problem. But then if you want to subclass that particular uh, singleton class, then subclassing on inheritance would not be possible for that particular singleton class, right? So we'll quickly see the solution that the singleton pattern provides. It says define a static method of the class that returns the singleton. Okay, create a class with the class operation get instance. Okay, let me go to the implementation first, and then I will come back to the slide. Let's understand this implementation, then we'll be able to better understand the implementation given by the singleton pattern. Okay, this is my public class service factory. So this is a factory which is implemented using a singleton pattern, right? The first important thing to notice is that the constructor of this particular class is private. The constructor of the class is made private so that no class can instantiate this particular class, right? Then next, there's a static instance of this class which is created here, and it is also private, right? So there's a private static instance of this class which is created when the class is first invoked, right? Then additionally, there is a static method which is called get instance, which returns this particular instance, right? I repeat, there are three important things that are made to convert any class into a singleton class, right? What you have to do, the first thing is to make the constructor of the class private so that no other class can instantiate this particular class. It is the same class only which is responsible for creating its own instance and maintaining a handle to that instance. So whenever every other class needs an instance of this particular class, the static method get instance returns that instance, right? So the class itself is responsible for maintaining the singleton aspect of it, right? So the first thing we did was to make the constructor private. The second thing we did was to instantiate the class, create an instance of the same class which is static and private, right? So again, this particular instance cannot be invoked outside, right? It is passed using this, it is passed outside. This instance can be invoked outside only through the call of the get instance method, which is also static, right? Okay. Now this kind of instantiation is called an eager instantiation. right? In singleton pattern, when we are implementing a class as a singleton, this particular kind of initialization is called eager initialization, wherein we are creating an instance of the class, right, even before the first time the get instance method is called, right? Even before the first time the get instance method is called, the service factory creates an instance of the of itself, right? And whenever a get instance is called, that instance is returned back, returned to the method which invokes this. This is called eager initialization. There is another implementation of the singleton pattern, which is called lazy initialization, right? So what do you do in the lazy initialization? The first instance of the class which is implemented as a singleton pattern is created only in the get instance method, right? I'll just explain this implementation again. So here you see we again have the constructor which is private, then the instance attribute of the type private static is initialized to null, right? So it is not instantiated here itself. But when first time the get instance method is invoked, you check if the instance is null. If the instance is null, then an instance of the service factory class is created and it is returned, right? This is called lazy initialization. Now, another important aspect associated with this is that this particular method, okay, and just what happened? Okay, this particular method, get instance, right, has to be placed in a critical section, right? Because there, in a multi-threaded application, there could be chances that two applications, two threads at the same time invoke the get instance method, right? And we do not want two instances of the factory class to be created, of this singleton class to be created, right? So in that case, this particular method has to be placed in a critical section, and that is the reason the word synchronized is added to the get instance method, right? This synchronized word, the keyword that is available in Java, right, helps us to handle the critical section if there are multi-threaded applications, right? So this no two instances, this synchronized word helps us to place this particular method into a critical section so that no two instances of the same of the service factory class get created if the get instance method is invoked simultaneously by two different threads of invocation, right? And then this instance is returned to the calling function. Okay, I think I'll move ahead. No questions. I hope this is clear, right? So this is lazy initialization, and the previous one was the eager initialization, right? So your lazy initialization is required in case of multi-threaded application. In case of multi-threaded application, the creation step of the lazy initialization logic is a critical section and must be placed in the synchronized must be placed using the synchronized tab, right? Which one is better, right? Lazy initialization is usually preferred. Why? Because the creation work, right, which perhaps might be holding on to expensive resources, is avoided if the instance is never actually accessed, right? So in the second uh, method where we had lazy initialization, if the instance is never actually used, then there is no need to create the instance itself, right? So lazy initialization has one advantage in this aspect, that if your instance is actually holding on to expensive resources, then why do you actually create that instance initially and just keep on holding it? And there might be case that the instance is actually never used, right? So the lazy initialization is preferred in that aspect. The second thing is, there might be chances that instance creation itself requires some complex conditional creational logic, right? So in that case, you have to place it into the get instance method, right? You can use anyone, right? Lazy initialization is preferred in actual implementation, but while writing code, if required in the exam, it is totally fine whether you write it using eager initialization or lazy initialization. Okay, I will take up 5 minutes break here. We will come back and we will implement the factory, the cake factory that we have created, and we will implement it using a singleton pattern.